just in here today. Let me explain what's going on here. First off, here's our source, 120 volts. Running through this wire here, it's going to that terminal block. The hot wire is coming over here to these two capacitors. There's two in parallel, and then the bank is in series, so it's a hairpin configuration off of the hot wire. And that's going into the MOT. And coming out of the other side of the MOT, it's going to another capacitor in series. And that's going back to the neutral wire coming from the source. Okay. Barely any. The first thing I noticed was on the ground of this MOT here to the earth ground. Did you see that clip back there on the chassis? I was seeing a 35 volt potential, which was really interesting. I couldn't do anything with it because as soon as I tried to use it, it was just deplete instantly. So I know there was hardly any current there, but there was definitely 35 volts potential. It seems like the MOT somehow raises the ground potential up from where natural ground is, I guess. 35 volts higher somehow. Anyway, that's not what I want to show you. What I want to show you is the rest of this. So coming off of this neutral leg of the MOT, which this capacitor here is going to the ground wire coming from the source. So we've come off of the neutral side with that red jumper there, and that's coming over here. Now what this is just a single capacitor here in the front, and it's now in series with this other red clip, which you see is going over here to this chassis. This is just a 12 volt, or it's just a power supply thing. So, I've got it wired in to where I can turn it on and off. There's outlets on the back. Anyway, I'm assuming that the frame is grounded. Then we've got the rest of these capacitors here. There's 7 more that are in parallel here, and what I'm doing is I'm running between this one. So instead of connecting the 7th one to this series capacitor here, I'm running that itself through this 100-watt light bulb. Okay. Now, we don't expect a whole lot of current to be traveling through this circuit because of 2 separate hairpins. Now we have some reactance here that's acting like a resistor and allowing some through there. We thought. You would think, I can say. But here's our 100-watt bulb. Now it ain't lit all the way, but it is lit, and it's got maybe 20 watts into it, I would say. But the interesting thing is that yes, when we saw before, when we added reactance to the hairpin, yes, it does become the more reactance, the lower the resistance is, the more current actually does flow through the circuit somehow. Don't know how, but it does somehow. But in this case, with this setup, with a hairpin on both legs, and we're coming off of that to another hairpin, and then we're using this other bank, and I was originally using this rotary to connect this bank instead of the light bulb, and I was seeing some really good sparks off of it. But I then went ahead and just threw the light bulb there just for the hell of it to see what would happen, and I'm seeing that there's real constant current going through there. So then, of course, I had to see what we were actually drawing from the source, and I think you'll be surprised. And we go up here and look at this kilowatt meter. We're going to look first at the amperage. Oh, it's 0. We're going to look at the watts. Oh, it's 0. The volt amps, they're 0. 60 hertz, power factor, 1.0. Kilowatt hour usage, only been running for 5 minutes. I'm going to let this run for a while, and I'll do another video in a little bit here after an hour or so. Confirm we don't have any accumulation here. But nothing so far. What is up with that? Are they coming from ground? Maybe. Are these other capacitors even needed? Maybe not. I'll play with it some more and find out. Thanks.